Okay, so now we have a scanner that scans 100 ports, but the problem with this scanner is that this scanner is very slow. And we know that Go has a very important feature called concurrency. So what we are going to do in this lecture is to use concurrency to build a more faster scanner. So what we are going to do is we are essentially going to use or put all of this functionality in a Go routine, and then we will call this Go routine. But before we do that, we have to make sure that all the Go routines are run properly before the main function is finished execution. Because if the main function finishes before these Go routines are run properly, what will happen is that we won't see any results here, and the Go routines will run in the background and return the results, but the main function will have already finished executing, so you won't see anything. So let's create a function called function, and this function will be, let's say, called scan port or something like that, and this will take the port number, which would be port, and it would be of type integer. And then this function is going to perform this functionality. So I'm going to copy this functionality here, I'm going to cut it, and then I'm going to put it here. So we can hard code the IP address here, so we don't have to give IP address every time, but you can modify the function. And the next thing we need to do is, instead of I, we need to define port. It should be port here, and then at the end we should close the connection properly. So connection dot close, so the connection is not left hanging. Now we have put all our functionality that we defined here into this function, and then we can simply say go scan port, scan port, and then we can simply give the port number here, and it will run the program in concurrency. But there is a problem with this program, because if we run it like this, what it will do is that it will go to 100 iterations and it will exit, and before we can check that if there is any port open, our main program will have finished. So what we need to do is we need to introduce a wait function. So Go has a very efficient feature called wait group. So what we can do is that we can add wait groups to the queue and then wait for them to finish. Once everything has finished, it's like a counter, so you add something to a counter and then wait for it to finish. Once it has finished, and once the counter comes back to 0, the main execution stops. So what we can do is we can define a variable here. I'm going to call this variable as WG, it represents wait group, and then Go has an internal package called sync.waitGroup. So the type of the variable is sync.waitGroup, so it contains a wait group that will help us in keeping a track of how many Go routines we have started. The next thing we need to do is we need to add elements to this wait group. So wait group dot add function will add 1 each time this loop is iterated. So whenever a Go routine has started, it will go into this, it will start adding a counter, and then once the Go routine has finished, we'll exit this counter. But if you go to this function, you have to see that go scan port. So once this Go routine has finished properly, what we want to do is we want to finish or reduce this counter here. In order to do this, we have to pass this object into this function as well. So what I'm going to do is I'm going to pass a pointer to this wait group. So it should be something like this, sync dot wait group. So now this function has a pointer, and then it can use this wait group variable inside this function. So once it has finished completing, we can do it. We can add a defer statement here, wg.done. So what this function is, when this function goes out of scope, it will reduce this counter again. So here we are adding this counter wg.add, and then once the go routine has finished, we can decrease this counter. Unless this counter goes to 0, this function will block, this main function will be blocked in a blocked mode. And then I'm going to pass wg here. I have to pass the reference to this wait group, not element itself. So now almost our functionality is completed. The last thing we need to do is we need to add a wait function here, wg.wait. So this function will check if this counter has returned to 0 or not. So here we are incrementing counter. When the go routine finishes, we are decrementing counter. So this works for all the 100 iterations. So when the iterations are, unless this wait wg.wait determines that this counter has returned to 0, it will be in a blocking mode and it won't close this main function, so it will wait here. So if I run it again, there is some problem here, invalid memory address.